So a very good morning to all of you. I welcome back you on my channel. As in previous video, we discussed about history and future of IoT. So now in this video, we are going to discuss about differences between the similar terms like IoT, M2M, IIOT. You will listen and you will get confused between these three terms, as the meaning of these three terms, definition of these three terms are equally same, but these are not the exactly same. So now in this video we will discuss about IoT, M2M and IIoT, that what are the difference between these three technologies. So let's start. First of all, IoT versus M2M. So in this, while many use the term interchangeably, M2M and IoT are not the same. IoT needs M2M, but M2M doesn't not need IoT. So both terms relate to the communication of connected devices, but M2M systems are often isolated, standalone networked equipment. IoT systems take M2M to the next level, bringing together disparate systems into one large connected ecosystems. M2M systems use point-to-point communications between machines, sensors, and hardwares over cellular or wireless networks, while IoT systems rely on IP-based networks to send data collect from IoT connected devices to gateways, the cloud or the middleware platforms. So as from this you can read that what is the difference between IoT and M2M. Now I will tell you the difference in a tabular form, so it must be more clear to you. So as you can see, abbreviations for M2M and IoT. M2M stands for machine to machine and IoT stands for Internet of Things. So M2M is a concept where two or more machines can communicate with each other. Here you can see M2M is a concept where two or more machines can communicate with each other and carry out certain functions without human intervention. Some degree of intelligence can be observed in M2M model. And on the other side, IoT is an ecosystem of connected devices via internet. Mention the term via internet. In IoT we need internet, in M2M we don't need internet. So where the devices have ability to collect and transfer data over a network automatically without human intervention. IoT helps object to interact with internal or external environment, which in turn control the decision making. So as you can see in M2M we also don't have human intervention, and in IoT we also don't have intervention, but in IoT we use internet, whereas in M2M we don't use internet. So now connection type. The connection type of M2M is point to point connection, but in IoT the connection type is through IP network using various communication types. In M2M, old proprietary protocols and communication techniques are used, but in IoT, Internet Protocol is used commonly. So in M2M, linear value chain is used, but in IoT, multi-sided value chain is used. In M2M, for monitoring and control of one or few infrastructure asset, but in IoT to address everyday needs of humans. In M2M, sharing of collected data. Data collected is not shared with other applications, but in IoT, data is shared with other applications like weather forecast, social media, etc., and improve user experience. In M2M, devices usually don't rely over internet connection, but in IoT, devices usually rely over internet connection, as in the term IoT, internet is the main thing that we use. So in M2M, the scope is limited, but in IoT, large number of devices are included, so it have a huge scope. But in M2M, less scalable than IoT. IoT is more scalable due to cloud-based architecture. In M2M, remote monitoring and fleet control are the examples for M2M. Smart cities, smart agricultures are the example of IoT. In M2M, B2B is used, and in IoT, B2B and B2C is used. These are the business types that we use. In M2M, vertical integration is used, and in IoT vertical and horizontal both integration can be used. M2M sensors and data information are the related terms to M2M. End users, devices, wearable, cloud and big data are the related terms to the IoT. So these were the some differences which will help you to understand the main difference between M2M and IoT. As I mentioned before, IoT needs M2M, but M2M doesn't need IoT. In M2M, we connect two or more devices to communicate in a small range so that they can work without human intervention automatically. But in IoT, we connect many devices across the world with the help of internet so they can communicate with each other without human intervention. So this is the main difference between M2M and IoT. So you can see another table also in which we simply differentiated the M2M and IoT. You can read this by yourself. These are the same differences I explained before, so you can read it by yourself. So going to the next technology, that IIoT. So IIoT stands for Industrial Internet of Things. IIoT, Industrial Internet of Things. Other than the IoT we mentioned above, there is another similar concept called IIoT, stands for Industrial Internet of Things. Both concepts have the same main character of availability, intelligence, and connected devices. The only difference between these two is their general usage. While IoT is mostly commonly used for consumer usage, IIoT is used for industrial purpose such as manufacturing, supply chain monitor and management system. This illustration below will give you the clear picture about both concepts. So IoT is used for day-to-day needs or for the simpler consumer usage, but IIoT is specifically designed for industrial purpose, used in manufacturing or monitoring the systems in industries. So 10 ways IoT differs from industrial IoT. The first point is security. Second is interoperability. Third, scalability. Fourth, precision and accuracy. Fifth, programmability. Sixth, low latency. Seventh, reliability. Eighth, reliance. And ninth, automation. 10th, serviceability. So now I will explain you in deep that what how it differs from these. So first point is security. Security is critical for all IoT solutions, but industrial IoT solutions require more robust measure. A disruption of a high volume manufacturing process results in lost production costing millions of dollars per day. So as you can see in IIoT, security is very important, because if we fail to provide security and something happened, then it will cost you around millions of dollars per day. But in IoT, the security is not as much as needed, that if it fails we can bear it. A takedown of the electrical grid affects economic activity for millions of people and jeopardizes national security. IIoT solutions employ a variety of advanced security measures, from secure and resilient system architectures, specialized chipsets, encryption and authentication, threat detection to management processes. So this was all about security. IIoT systems are more secure than IoT. So this is the first point, that IoT differs from IIoT, that we need more security in IIoT. Second point is interoperability. Industrial IoT solutions must coexist in an environment with a significant amount of legacy operations technologies, including SCADA, M2M, and other purpose built manufacturing execution systems. These legacy OT systems are not going away. Industrial IoT solutions must integrate, support various protocols and data sets, and work reliably with these manufacturing systems. Equally important, IIoT solutions must integrate with back office enterprise resource planning systems. Fourth point is precision and accuracy. Industrial operations require higher level of precision and accuracy. Automated high volume, high speed manufacturing processes are synchronized to milliseconds. Quality assurance systems detect minute variations and take immediate correction actions based on those measurements. In this environment, close enough is not good enough and result in lost efficiency, downtime, and revenues. Industrial IoT solutions must support operations where high precision and accuracy are business as usual. Programmability. Industrial and OT systems, from programmable logic controllers to machining equipment, are frequently reprogrammed and reconfigured to support new processes. This programming is done remotely on site or in the field. Industrial IoT solutions supporting industrial and manufacturing applications must provide the same flexibility and adaptability to support operations. Sixth point is low latency. In a high speed continuous production system with sensors monitoring every aspect of the operation, every second matters. Anomalies must be detected and corrective actions applied in near real time. Any delay in detection, assessment, decision making, and execution would be costly in terms of worker safety, product quality, cost, and lost revenues. Industrial IoT solution must similar to build to support the low latency requirements of some industrial applications. And the seventh point is reliability. Industrial systems operate in long time scalable before replacement. 30 to 20 to 30 years is not uncommon. They operate in harsh environments, sometimes subject to extreme heat, cold, high vibration, pressure, and dust conditions. They may operate in remote locations far away from headquarters. Industrial IoT solutions may be subject to the same condition and requirements. They must be hardened to support high availability, withstand high duty cycles, and operate reliably and within tolerance day in day for years and years, with shutdown only for maintenance. And the ninth point is many industrial processes are highly automated from start to finish with limited to no human intervention. IoT solutions operating in industrial environments need to support a range of autonomy requirements. This may entail building intelligence into the edge devices, incorporating control and automation logic in the gateway, or incorporating deep learning capabilities in the system design. In addition, it must be programmable and integrated with legacy or new manufacturing execution systems. And the 10th and the last point is serviceability. Industrial system must operate reliably and predictably in harsh conditions for years and years. Supporting this level of performance requires regular maintenance from in-house and field service technicians. IoT solutions operating in industrial environments must be serviceable in order to sustain the levels of performance required, from swapping out sensors, updating firmware, to configuring gateways and servers. The ability to maintain industrial IoT solutions over its entire life cycle is an essential requirement. So in IIoT there is focused development. In IoT there is not focused development. And now what do you mean by focused development? IIoT uses more sophisticated devices to extend existing manufacturing and supply chain monitor to provide broader, more detailed visibility and enable automatic controls and accomplish analytics. On the other hand, IoT is developed with the concept of using smart devices to improve consumer convenience, where human interacts with devices to gain some benefits. For example, connected home appliances will reduce your monthly bills by managing your resources usage, such as automatically turning off electricity when you leave home or adjusting the room temperature based on current weather. And the next point is degree of application is more in IIoT. Since IIoT is developed to handle critical machines, IIoT uses more sensitive and precise sensors in the plant, including more location aware technologies on supply chain side with sophisticated advanced control and analytics. However, on the contrary, IoT uses a simpler application with low risk impact. It is undoubtedly that IoT device will grow higher with less expensive price than IIoT, considering its production volume and technology capabilities. And the last point that separate the IIoT with IoT, separated area of interest. IIoT connects critical machines and sensors in high stakes industries such as aerospace, defense, healthcare, and energy. These are the systems in which failure often result in life threatening or other emergency situations. but in IoT, on the other hand, tends to be consumer level devices with low risk impact when failure happens. They are important and convenient, but breakdowns do not immediately create emergency situations. So this was all about the differences between IIoT, M2M, IoT and IIoT. So now in next video we are going to discuss about that how uh, what are the platforms we used in IoT and what which companies are working on IoT. So see you in next video. Like, share and subscribe.